Okay, thanks, Nikhil, for the introduction part of this course. And first of all, there are a couple of clarifications I'd like to make before just heading off. So, what I'm going to present now, it obviously is a part of the entire 5-day program or the 5-day structure which I have in mind. But this is just to give you guys a heads up, understanding as to what you can expect out of this course. Secondly, this course is not just designed for students, but it's designed for students as well as the professionals who are professionals like, for example, the maybe the reservoir engineers or the geologists or the production technologists who are working in the oil and gas industry. So I presume currently we have an audience of, I don't know how many, 55, right? So I presume that it's a combination of both the types, and I hope that this course will be beneficial to each and every one of you. So I'll just take you through the precursor of the course, and in order to just make you aware as to what exactly is this data science and machine learning, and how is it applicable in the oil and gas industry. You know, when you say like data science and machine learning, it's the trending topic in all over the globe right now. And for oil and gas, it's we have fallen. We are lagging the most of the industries in this regard. But recently, what I have seen, because of the low oil prices, just because of the cut in the operational expenditures of all these organizations, right? People are trying to move to digitalization, and data science, machine learning, automation, all these things are a very inherent, are a very important part of this digitalization move which the industry is going through. So especially people who are young professionals, especially students who are pursuing their petroleum engineering degree at this particular moment of time, it's absolutely important for them to get a. I'm not saying to you'll be an expert in data science and machine learning and by studying it or by taking my course for 5 days, but but one thing is for sure, that you'll get started up in the right direction. You'll get the right head start, and you can pursue a career in data science and machine learning in oil and gas. Just to give an example, this is from my personal experience. Uh, Today, I have gone through a number of jobs, and I have seen people move through a number of jobs. This data science career, if we become industry agnostic at this particular moment of time, and if we don't talk about oil and gas, this data science career is moving pretty fast these days. People are paid really high for applying data science in generic day-to-day problems. For example, maybe a sales problem, or maybe many of my friends are data scientists in, for example, Flipkart or Walmart or Amazon. So in terms of remuneration, this part is pretty high. Now, if you combine this data science in oil and gas, right? These people who are my friends who work for non-engineering problems in data and in data science, they cannot straight away come and move to oil and gas industry and start working into oil and gas, which are engineering problems. It's not possible for them to have the same effect in the oil and gas industry, because they do not have the domain expertise. The advantage which you guys, the young professionals and the students, are is that you guys have a very decent background of petroleum engineering, of the geosciences. You guys have an understanding of the domain of which we are talking about, and data science in oil and gas is nothing without domain understanding. So again, applying application of data science is more of a domain thinking as compared to a generic data science application in a generic problem. So number one, just keep in mind, domain is the number one thing, and then with data science, you can add a lot of value and solve oil and gas business problems. So this is something which I would have I would like to share at the top of my presentation. And whatever I'm going to present to you, it's just a precursor to what I'll show you in the 5-day course. Uh, so I presume I can just start with what I have. So yeah, so just at the end of the course, you will be able to boast that you guys work with models, not on the left side, but on the right side of the picture, right? So this is all, and you'll have all those input data of the oil and gas petrophysical parameters, and the output you'll have the estimated ultimate recovery. So at least you'll be able to tell that you work with models. Yeah. So what are we going to cover in this particular 5-day course? I would not take this webinar to like to 1 hour or something. I'd like to cut short as soon as possible, because there's no point discussing which we are going to discuss in the upcoming course. I'm going to tell you now what I will tell in the course. Just a short summary. So if you the agenda has already been shared with Nikhil, and I think he has the course outline and stuff, but still I'm going to so we are first where does this AI and ML in data in oil and gas comes in. It comes from digitalization, right? So this data science and machine learning, artificial intelligence, deep learning, they are a part of the entire big digital framework. So we'll have an understanding of what digital is first. What is the digitalization framework? Where is the oil and gas? Where does oil and gas fit into this digitalization framework? And take it forward from there. Next, I'm going to talk to you about why and what of data science in oil and gas. As to in generic, what is the career prospects for a data scientist or for a machine learning engineer or a data analyst in the upcoming future. But specifically, this will be fine-tuned. This you can all find on if you search on Google or YouTube. But a fitment to oil and gas, I'll discuss with you about the fitment with the oil and gas industry. So why have we started using data science now? We had why did we not use it like 10 years earlier? Why did not we start 10 years earlier? Why it's such a push using data science, using digitalization, using machine learning in today's world? So that's what I'm going to discuss as the second point. Third, I'm going to talk about physics-based versus data-driven modeling, because as you know that the oil and gas industry is highly empirical driven, right? It's heavily physics driven, be it with the fluid flow, be it with the temperature profiles, be it with the pressures. It's highly governed by physics and the laws of physics, right? And we perform certain experiments and we fit those independent parameters to an equation, and that equation has been used since ages, right? So that's a physics based which we currently use in oil and gas domain. But what exactly is data driven modeling in oil and gas? How do we do it, right? So where we have abundance of data in oil and gas these days, how can we make sense out of that abundance of data? How can we pull out information out of that particular data using data driven modeling? What is the difference between physics based and data driven modeling? That's the third part I'm going to cover. The fourth part, then I'm going to tell you about the basics of machine learning, right? What exactly is machine learning? Where did it come from? The generic subdivisions between supervised, unsupervised, reinforced learning. That's all. That's a very basic. I'll just touch upon the basics. Maybe in some cases a bit deeper and going into the maths. But for generic case, just the basics, because all this you can find this anywhere, right? The basics of machine learning and all. But what most important this course will do will give you an alignment with what you will do with this oil and gas stuff and machine learning. It will give you the right blend, the right intersection of data science and oil and gas. So after discussing this basics of machine learning, I'll show you some of the ML use cases for oil and gas. I have planned like some use cases. It's not possible to discuss all the use cases with you guys in you know in a 5-day course. It's absolutely not possible. So I'll pick and choose some of the use cases and discuss with you. You may just to just continuing, and then I'll get back to that point. Then I'll talk to you about the machine learning workflow, which you will apply to any machine learning problem, whether it be oil and gas or non-oil and gas, whether it be an engineering problem or maybe whether it be a non-engineering problem. And then we can align those use cases to these machine learning workflows, right from data gathering to data pre-processing to exploratory data analysis to feature ranking selection, selecting the right data to train the model. How do we validate the model? How do we test the model? What is hyperparameter tuning? And this is all with the oil and gas data set I'm talking about. And then finally, there's the last stage where we deploy the model for the client or the public use. And I'm not going to touch about talk to you about model deployment, because that is another 5-day course on its own. So I'll talk to you about ML workflows, and then I'll move on to specifics of machine learning, which is supervised learning, and the applications related to supervised learning, in which I'll cover 1 or 2 examples related to oil and gas, and especially related to artificial neural network. We can talk to you about linear regression, but actually linear regression is not data science. Linear regression is not machine learning. People qualify it to be a machine learning algorithm, but it's not. So I'll talk to you about artificial neural networks and one of the oil and gas applications with artificial neural networks. Then I'll move on to unsupervised learning, which is again a very important part of the data science gambit of opportunities. So there also I'll follow the same structure and relate it, and I'll have one of the algorithms which I call the K-means algorithm to solve oil and gas problem, oil and gas business problem, or oil and gas technical problem. So that there I'll cover another use case, right? Following that, the most important, not the most important, one of the most important stuff, which is model evaluation, right? How do you evaluate a particular model? What are the evaluation metrics when you finally build a model? How do you say that this model is good or bad? What is the evaluation mechanism? That's one of the for both supervised and unsupervised learning. So that will be covered. I presume most of the people, most of you guys have a question about Python as to whether this will be a Python driven course, whether you need to know Python. No, you do not need to know Python for this particular course. Python is just a language in which we tell the system, tell the machine, tell the software to, to run our, to solve a business problem. The main idea is to understand as to how machine learning is important to oil and gas, and not to understand Python. You can go and you can have free courses on Python on YouTube, on Coursera, or whatever it is, or maybe Nikhil might be having some of the courses. So you can learn it from there. But the idea is not to teach you to Python. I'll just give you an introduction to Python and some Python libraries which we use in oil and gas. For example, NumPy or SkyPy, or for plotting, we use Matplotlib or Seaborn. So these are the libraries which we use generally. So this is, I'll just give you a heads up. I'll give you some cheat sheets related to that, and that will be pretty useful to you guys. And finally, having if I have the time, I will tell you how will you structure a machine learning project. How will you start from a project? What are the things which will you keep in mind when you are building a model for any problem, right? For any oil and gas engineering problem, non-engineering problem, whatever it is it. So you will get to have an understanding as to whether most of the time accuracy is not the accurate figure to look into as an evaluation metrics. So all these sorts of understanding, how will you choose the test data, the train data, how will you do some exploratory data analysis, how will you select the features. So all these things will be covered in the structuring ML projects part. So having said that, and finally we obviously will have some quizzes, and you'll be free to ask any questions. And by the way, you can stop me at any moment of time, because it is for you, it is not for me. You can stop and ask any question at any moment of time if you are having doubt as to what exactly this course is about. You might find you might find a number of courses related to data science, machine learning, artificial intelligence across. That's the web is full of that, right? But the USP of this course is its alignment and fitment with the oil and gas industry. You will not find even a single course with the which will tell you about how learning is applied to oil and gas industry. This is a course fully designed by me and one of my colleagues, and we have worked pretty hard on it. So the idea is to expand it to the oil and gas, oil and gas young professionals or students, and to just make them aware that this is the entry path to an oil and gas industry. This was not something which we did like when I started my career 12, 13 years back. This is not we did, but this is something which I think you guys should get started with, at least to get a penetration into oil and gas, and to to have a differentiation with respect to other people, maybe in from the knowledge front or maybe in the job market. It will be pretty useful to you guys. I'll just give you a heads up. I have some slides which I have prepared, or which is like just a intersection. I'll just show you some slides. So yeah, before that, I just want to tell you something about me. My name is Ishan. I am a petroleum engineer who has done his bachelor's in petroleum engineering from Indian School of Mines, which is now IIT Dhanbad. And I have done my MBA from Indian School of Business, which is again just because of the oil and gas, market. This was something which I did by choice. I have worked with more than 12 industry, approaching 13 in this approaching 13 in the industry, whether it be Shell. I have worked across 8 years with Shell, doing core oil and gas jobs, doing in the field also, in the office also. I have worked with all these companies like the IT companies like Wipro and Tech Mahindra, and to understand as to what is the IT landscape and how do these companies fit to the to the big majors like Shell and Exxon, right? So I have an understanding of that also, with an experience of digital in both these types of companies. Currently, I'm working for Schlumberger, and in the digital space as well, in the production digital space, and trying to solve business problems for the clients from using their platform which they have. And I'm very and the most important thing why I'm having this course is because I'm very passionate about data science. This is the future of the industry, of the oil and gas industry, because if you look at the career opportunities which you'll have as a petroleum engineer, as a young professional down the line, this will be on the top priority of most of you guys. So that's why this is important. These are some pictures. I've been to Siberia at minus 37 degrees Celsius, worked there 12 hours shifts at the start of my career. So yeah, just wanted to show you that. So why I'm here. I told you, share my learnings acquired over my diverse experience and answer your questions. Most important, your questions related to data science and its application in the oil and gas industry. So what will we do? As I mentioned, it's a precursor to the planned course. Why is data science relevant to oil and gas? Why is it a career option? And we are currently at the crossroad of petroleum engineering and data science, and where to move forward from here. So this was all about me and why I'm here. So yeah, so what I'm going to so this is important. So what is digital, right? So digital is the in thing in the oil and gas market. When you think about digital, what are the companies which comes to your mind? These are the companies which comes to your mind, which apply digital technology, which helps the organizations move towards their digital transformation, right? These companies like McKinsey, they chalk out these digital transformation plans, the business transformation plans. For example, for companies like Shell, companies like Exxon, companies like BP, you have Accenture here, you have PwC here, you have Wipro here. So all these companies are the companies which basically devises the digital roadmap for all these organizations, oil and gas organizations, and these all oil and gas organizations take help of these companies. So in general, if I tell you what is digital, so this is what is digital is. Digital is data. So you have, for example, I'll just tell you with a short example. If you have an Apple Watch, right, it consumes lots amount of data, right? So that's the data part. And how do you make sense out of the data which this app, this digital watch is consuming, right? Using analytics, using you're making sense out of that data. And how does it do analytic using connectivity? How does it these things, this connectivity allows the digital things to talk to the entire network. And that's the thing. So any device, any process, anything which has to do with data analytics and connectivity is digital. And this is and you can fit there's a digital framework which I can talk to you about, in which what covers digital, what are the 9 components of digital. So just I'll talk to you about much about this later in the course, but just to give you a brief framework of what a digital framework is. A digital framework is all about data. Data is the bloodline of digital. Without data, there is no digital framework, because you will not be able to do anything without data. So that's the first component of a digital framework. The second component is the IoT. How do we acquire data? Using this industrial internet of things devices, these sensors, these hardwares, right? So this is how we acquire data using IoT. So that's the second component of digital. The third component, if I talk about, and my course, on which my course is based upon, is data analytics using AI and ML. So this is how you make sense out of data. You acquire the data, convert data into information, and help the organization solve their business problem or drive value out of the data which they have. So because you may have the best model, you may have the best architecture, you may have the best model deployment, but until and unless it solves somebody's business problem, until and unless there is value in it, nobody is interested. You might it might be the most complex model in the world, but I may not be interested, because it's not it's not reducing my operating expenditure, it's not reducing my HSE exposure. So in the oil and gas domain, I'm saying. So that's pretty important. So this data analytics is the third part, followed by automation, right? Most of the things today, if I talk to about automation, and the 2 examples which I have mentioned here, RPA and drones. RPA is robotic process automation, which is essentially the automation of the repetitive work, and drones, which is essentially used in the oil and gas space to reduce travel time, to monitor the rigs, to monitor the wells, to monitor the surface facilities using without going to the site. So there's a huge, hue and cry in the world with respect to automation, as to this might take away the jobs. Partly it is correct. I'm not denying that, but it's not all the jobs which you're talking about. We are talking about this 15 to 20% of the jobs, which are highly repetitive jobs. Maybe, for example, in oil and gas, if I can think about, is joint venture accounting, correct? So this joint venture accounting is something in which, if we have 2 companies, for example, they have a joint venture, and what is the invoice which should be, or what is the profit share between these 2 companies, right? If a person does it day in and day out for every month, it's repetitive. Why don't automate this task? So this is one of the part of digital automation. Then we have this cloud and edge computing, right? Where do we store that the data which we have acquired using cloud, right? So all these companies, for example, Google Cloud or Microsoft Azure, or I can talk about Amazon Web Services. All these companies provide this cloud computing solutions to oil and gas clients. So oil and gas companies don't have their own cloud, but they hire these companies to provide these solutions. Either maybe in a public, obviously it will not be a public cloud because oil and gas data is pretty sensitive. So it will be either be a private or a hybrid cloud. So I'll discuss this about more about this on in the course. Then we have this blockchain. You guys must be knowing about crypto and Bitcoin and all these things. So all these this crypto and Bitcoin is an application of blockchain in the financial domain. In the oil and gas domain also, we can have a number of applications of blockchain. For example, the contracts, we can have smart contracts between the vendors and the companies. So that's another application. Then we have the ERP systems, which is that if we can talk to you about the Salesforce or the SAP system which we have, correct? So this is again, a part of digital framework. How do we do this digital? We do digital using agile and user experience. That's again an important component of digital. I'm not going to talk to you about agile or blockchain or ERPs in the course. We are going to talk about cloud. We are going to talk about data analytics and all this in the planned course. And then the most important thing for digital framework is people and change management. However hard may we try, maybe our model be the most robust or complex, until and unless the people are ready to take it or consume it, you will not be able to do it. So you have to manage the change in the process, the change in the digital transformation in the organization, and that's the most important component of it. So I think I have spent around it's 6:34. Okay, I'll give you a brief exposure of what I'm going to talk to you about in the course. So this is data analytics. So yeah, so I'll just just a small why and what of data science in the generic context, not in the oil and gas context. So if you see, this is the World Economic Forum jobs report data of 2020. So there's a growing job demand by 2025 by a number of 97 million, and most of it is related to data analyst, data scientist, big data specialist, or process automation specialist, and there's a decreasing job demand of 85 million, the prognosed or the anticipated numbers I'm talking about. And these are all the repetitive jobs which I'm talking about. And the similar is the case with the oil and gas industry. It's no different. So all the repetitive jobs will be gone, and if you'll have to build on your skill set or add on to your skill set, especially in this domain, to survive or shine in the oil and gas space. And this is what data science, I got this from from one of the websites on the internet, and I like this pretty much. This shows you the data science landscape, which we will discuss more about in the course. Coming to why data science in oil and gas, I have chalked out 3 or 4 reasons behind it. Why we did not have earlier, why do we have it right now? The most important reason which for having it right now is the availability of data in in huge format, right? We have today big data in terms, and big data is nothing. We have volume. Big data is related to volume. We have terabytes of data coming in. It's related to velocity. It's coming in at a very high speed. Every day we are having, like every second we are having data. We have variety of data. We have different sorts of data. In earlier we only used to have text data. Now you have images, and now you have acoustic data. You have image data. You have cameras, and number of things. So you have the varieties there, and you also have veracity. So that's the number one reason. Number two, if I can talk to you about, is the in 10 years ago, we did not have the computational capacity to consume this particular data. Today we have. So whatever speed the data is coming in, however, whatever the volume is, whatever the variety of the data is, we have enough computing capabilities and analytical capabilities to handle this. And similarly, is going the IoT sensors are also like increasing with this trend also. Coming to the oil and gas part of it is like we have the oil and gas business problems are pretty complex. it's essentially more of a modeling based work which we have been doing till now. It's more of a, I'm not going to say a, guesswork, but it's more of a probabilistic sort of work which we are doing right now. No? It's a probabilistic industry, if I may say so. And there's a huge uncertainty associated with any oil and gas business problem. Whether it be expecting, calculating the oil and gas volume subsurface, or the production rates, or whether the sand is going to come to the surface or not, or what is the impact of the hydrofrac job which we have done. Everything is probabilistic in nature. You cannot deterministically say that you are going to gain X amount of barrels per day from the reservoir. So what this data science will help you will make this decision more informed and less biased. We as humans are very biased, right? We if we know a particular field, if we are an operator, and for like if you give if I give you my example, if I've been working in a field for, like, for example, 5 years as a reservoir engineer or as a production technologist, I'll be obviously be biased. Without I'll tell you that this particular field will, or this particular new well will produce, for example, 100,000 barrels per day, which might not be correct. Maybe I have the experience, but this might not be correct. So this data science, what will help you, it will help you make a more informed decision about it. You do your physics thing, you do your modeling work, but if you have sufficient data from the field, that will any day augment the existing empirical process and equations, right? Next thing is, why data science using Python? Why do you want to use Python? You have R, you have Java. Why are you using Python, right? And having said that, I presume that most of you guys are petroleum engineers or like closely related to the field. Don't ever think like you cannot do Python or something, right? It's pretty easy. It's good to go. It's very intuitive. You can learn Python on the go, and and especially if you have a prior experience with any computer programming language, then it will be much beneficial. Even I did not have any experience, but I learned Python like on the go. So the three things which is most important, which I think why data science is being used, why data science using Python, is simplicity of this language. It's free, easy to learn, very simple syntax, very intuitive syntax. What you think in the mind is what you write as a code. That's like, it's pretty easy. Then it's highly scalable, just not it's, you can scale it to, it's open source, so that leads to immense scalability. And then most important part is the community. It's a very huge, support community around it. So whatever problem which you have with respect to Python, you can, that's always available on the web. You can find the solution on the web. So you can join a couple of community help desks for Python, and it's good to go. So it's simple. Even if you're facing problem, you have a community to help it, and it's scalable. So that's, I think, it's a three most important reasons for doing this. And if you just go by the data of Statista, Python is the most popular programming language in the world today. So this is what I wanted to show you. I'll not take this, presentation very long, but this slide I'd definitely like to present to you, because this is very intuitive, and this is just a thought process which I have in mind, and this is physics-based versus data-driven modeling. What we'll learn in machine learning, AI, data science, whatever, is data-driven modeling, and what we do in petroleum engineering is physics-based modeling. What are these two? How do we differentiate between these two? So this traditional modeling of currently in oil and gas, we do of a physical phenomena, maybe of a, for example, of a sand prediction, right? A physical phenomena. And how do we do it? We do it using variables. What are the variables which you are talking about? The variables that describe the features and control the behavior of the physical phenomena, right? There is x1, x2, x3, and x4 variables. We say that, okay, so maybe sand production is dependent upon water rate. Maybe sand production is dependent upon the drawdown pressure which we apply. Maybe sand prediction is dependent upon, the probability of sand production is dependent upon the geomechanical rock strength, right? So these are the 3 or 4 features which we are talking about. And the physical phenomena which we are trying to model is the probability of sand production, right? So so this is, we have identified these variables. Now we develop mathematical equations, right? We develop complex mathematical empirical equations to identify the relationship between all these variables. This is what we do even in a simulator or reservoir, even if in a grid, the grid based modeling which we do for a reservoir simulator, even whatever, if we do PETX Prosper modeling, inflow outflow modeling in Prosper, or the complete network modeling in GAP or Resolve, this is what we do. We develop complex mathematical equations using variables to model a physical phenomena. That's what we do, right? Just giving you an example. I'll not give you an oil and gas example, just give you an example of a projectile, right? What do you see on the left? You see a projectile, right? And there is a, you must have heard, you guys must have studied about it in high school, or maybe 11th or 12th, I don't remember, right? So so this is how a projectile looks like. You have an equation, you have the variables like velocity at which you throw the ball, angle at which you throw the ball, the gravity which is acting on the ball. So these are the things which are working to define the range of the projectile, right? But how does this guy catch the ball, right? Does he apply physics every time he catches the ball? These are the parameters, and this is the mathematical equation. If somebody throws a ball at him, this is what he has to, if you go by physics, this is what you have to calculate, the range, and you have to place yourself there to catch the ball. So the question is, can human brain solve physics-based problems? He's catching the ball. So obviously, yes, human brains can solve these problems. Does human brain construct and solve mathematical equations to solve these problems? Now we have to catch the ball. Does he, before catching the ball, does he think like v square sine 2 theta by 2g? What should be the answer? No, right? Obviously he does not. So how does he do it? How does the human brain solve physics-based problems? Through observations and learning, and through trial and error. So this is not the first time he's doing it. If he was a child, he might have missed it like 100 times or maybe 1,000 times. But as he grew up, he observed it, he learned it through trial and error. And how? Through data, through number of balls which were thrown at him. AI mimics human brain and thus uses data to solve physics-based problems. And this is what data-driven modeling is. I hope you got it. So this is the basic foundation of any AI, ML, deep learning, whatever you call it, right? These are just fancy names. These are just brand names, right? So, and ultimately, any data analytics problem mimics human brain, especially the artificial neural network and deep neural networks. Correct. So what is machine learning? Anything that gives computers the ability to learn without being explicitly programmed. That is machine learning, which was what was defined in the 1950s. This is what it is, right? Machine learning is just a subset of artificial intelligence, and deep learning is again a subset of machine learning. Deep learning is nothing, it's just a fancy name given just because of the today's hype of data science. Essentially, it's machine learning with 20 layers. We call it deep learning. It's nothing different from artificial neural networks. We call it deep neural networks. So essentially, this is how it looks like. There are certain drivers, characteristics of a machine of machine learning, which in the interest of time, I'll just like to skip now and we'll discuss in the course. These are the machine learning types: supervised, unsupervised, and reinforcement learning. What are these supervised learnings? Supervised learning is something in which you have labeled data. For every X, you have a Y. In unsupervised learnings, you just have X's, right? So, so for example, I'll tell you. So these are the different types of algorithms. These are the most important algorithms of supervised, unsupervised, or reinforcement learnings. Like every month, you'll see a new algorithm coming up in the market. Obviously, all are not very popular and all are not very practical and all do not solve all the business problems. But these are the algorithms which we generally use in the oil and gas industry to solve problems. For example, if you look down here, we use our ANNs a lot. We use CNNs a lot for image recognition, for object detection, especially in well sites where you have camera and you don't want people to enter prohibited area. So how does this detect it? It detects it using CNN. You have long short-term memory. That's again, uh, 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 an algorithm which is used essentially for time series data analysis, for especially production forecasting. You have artificial neural network. Obviously, we use it. There are other machine learning algorithms like gradient boosting, random forest, decision trees, all these KNNs, and we'll talk about this in the course. Not all of it, but some of it. Uh, Then you have unsupervised learning, in which you have only x1, x2s, and x3s. By that I mean you have just a data. You have a random set of data which is fed, which you have in front of you, and you just ask the algorithm to identify clusters in it. So it does clustering based on its own understanding, based on pattern recognition. You don't say that for every X there is a Y. You don't need to train and test this stuff. So you have in this you have k-means clustering, hierarchical clustering, and whatever. You have different applications of oil and gas in this. We'll again discuss this in the you have other things like anomaly detection, which essentially I mean the outlier detection. You have huge amount of data coming in, right? Oil and gas, you have, like, for example, maybe you have wells ranging from 500 barrels per day to 1000 barrels per day, but suddenly you get a data set in which you have a well which is producing 5000 barrels a day. You cannot go through the entire spreadsheet and look out at the 5000 barrels per day. This algorithm which help you identify and separate this particular 5000 barrels per day data which you are getting, and that's pretty important. So that's used that anomaly detection or outlier detection is done using statistical methods or local outlier factor or isolation forest, whatever be the method. Then if you have multi-dimensional data, how do you reduce the dimension? You use PCS and all that. Again, we'll discuss this in the course. So what are the different problem types, right? Just to give an example of what is the input and what is the output. These are the generic problems, right? So if you look at it, we have three columns: input A, response B, and application. So what is if you see, for example, I talked to you about loan applications, right? So this is a loan application. So you input the loan application data to a neural network or to any other algorithm. What is the output which the company wants from you? So the loan application data, maybe a bank has data of maybe 100,000 people, and he wants to know whether based on that data, the next person, if I guarantee the loan to him, or if I grant the loan to him, whether he'll repay or not. So that's a problem which the bank has. Now it asks you or me to solve this problem. So this is the data which will go and input, and the output should be whether they repay the loan or not. And this is a generic application for loan approvals which the bank will have. So this is one of the example which is here. Similarly, there are examples for facial recognitions. You see the Google Translate, right? You give your you translate from English to French or French to English using, this is all CNNs, convolutional neural networks, and natural language processing stuff and all that. Audio clips, car camera, and other sensors. So you can go through it. So these are the generic applications. In the interest of time, I'm not discussing each and every of it. Now coming to the oil and gas stuff. So I have just given you 12 examples here, and it goes on and on, depending upon what you want to do with, depending upon the business problem. So you have examples from completion and well spacing optimization to recovery per, EUR, estimated ultimate recovery per well. How do you want to estimate the EUR per well using the data of 100 wells if I have? So how do you estimate the 101st well which we are drilling? What will be the ultimate recovery? Currently, we are using, for example, DCA, decline curve analysis, in the Schlumberger OFM, software. But how do we do it using data? I don't want to do the curve fitting. I just want to use data and use some algorithm which gives me a close to right answer. This is how you can use machine learning here. How do you do liquid loading detection? Liquid loading is again a problem. If you look at flag number 3, which is liquid loading detection, liquid loading is again a problem. I'll just discuss this in the consequence lines. How will you you know detect ESP or the PCP failure? These mechanical pumps are subject to fail every 1 year or 2 year. How will you use machine learning to predict their failure in advance, so that your supply chain problem is solved, so that you fix that before it is your production deferment is minimized? All these all have business implications. How do you interpret missing logs? How do you do geomechanical log predictions? How do you drill faster, not faster, but optimize your rate of penetration? How do you do fault detection through seismic data, gas tube distribution optimization, virtual metering? There are n number of examples, and you can optimize all these using machine learning algorithms, and depending upon the business problem. So this is, I'll not discuss each and every one of it in the course, but there will be some examples out of these which I'll discuss because yeah, it's still okay, I'll talk to you about later. Okay, next is, this is the machine learning workflow I was talking to you about. Maybe I'll skip this. I'll talk to you about this in the course. How does a machine learning workflow work, right from data gathering to processing, feature ranking, scaling, and finally model evaluation, and finally model deployment. How does supervised learning work? You have some data. How does forward prop work? How does back prop works? This is again a bit of maths in here. That's why at the start I mentioned that you need to have a bit of understanding about algebra and calculus. I don't need like a pretty deep understanding, but it should be a very basic understanding as to how to add two matrices, how the matrix looks like, how you do matrix algebra, how you differentiate things. There's no need of integration here. We only differentiate dy by dx. That's it. Just a basic level of understanding you can have. How this deep learning compares to a brain cell. I will discuss all these. It's pretty interesting actually. How does artificial neural network work? This is a generic architecture of artificial neural network. How does it work? So I will discuss this. This is one of the use cases I'm going to discuss, EOR prediction using artificial neural network. So here the objective is to find correlation between the estimated ultimate recovery and multiple well reservoir attributes, and use the model for prediction. So if we have data, like geological data, drilling data, completion data for a particular well, how do you say that this well is how do you predict the UR for that particular well using artificial neural network? Pretty interesting again. So I have a data of 500 dry fractured horizontal wells, 20 years of UR data. How do we establish a correlation, and how will we predict a 501st well? This is the data I have in terms of geology, drilling, and completion. We have porosity, thickness, water saturation, pressure gradient. And obviously, I'd like to say here that obviously not all data is important, and not all data is statistically significant, or not all data is used to predict EOR. That also the machine learning algorithm does. That's what it does in the feature selection model. So that's again an important thing. Unsupervised learning. I'll discuss this. What exactly is unsupervised learning? What are the applications of it? What are the different algorithms like k-means, hierarchical, or DB scan? I will discuss this, or liquid loading detection using k-means clustering. So here the objective is to detect the liquid loading for a well or a group of wells using historical data of existing wells. So we have, for example, 100 or 1,000 wells in a particular field, and we know if you guys are petroleum engineers, or if you guys are young professionals, you must be having little bit of idea of liquid loading. If not, then please tell me, I'll give you a small an idea. Liquid loading is a problem which occurs in tubulars in which the well is not able to flow just because below a particular rate, just because the liquid just because it gets heavier, and the liquid part of that particular stream comes out of the flow, and it blocks the tubing. So this happens at below a particular rate. If the rate of the gas rate of a particular well is very low, for example, it will liquid load for sure, because it will not be able to produce below that the critical rate, which is called the liquid loading rate. So we have to know that in the field we need to know that we need to produce above this critical rate, and we use Prosper for that when we do the inflow outflow modeling. But as a substitute to Prosper, if you have the historical data, you don't need the license of Prosper to do that. You have the historical data. Using that historical data of 100 wells or something, you can predict as to which well will liquid load or which well will not liquid load based on the data. And the data set which we are talking about is the gas rate, the casing pressure, the tubing pressure, the line pressure, and all that. So this is the scenario which I have discussed here, and yeah, I will discuss this case in the this is another example, geomechanical data clustering using DB scan. This is again used as an input to hydrofrac, because hydrofrac depends upon geomechanical data. So how do you cluster this geomechanical data using DB scan? That's again a business problem which we need to solve, and these are all relevant business problems. This is not something which I'm talking out of the blue. This is being practiced in the industry, and if you as a data scientist, are not as a data scientist but as a petroleum engineer, knows how to solve these problems, you believe me, you'll be you'll be very hard to substitute in today's day and age. So this is all about this, and as I told you, I'll give you a brief introduction to Python. What Python is, as I told you, it's easy to learn and understand, scalable, different libraries, active community user, right? The same slide, I think it's got repeated. And the different Python libraries, which are pandas, matplotlib, seaborn, numpy, sklearn, keras, and tensorflow are used for deep learning again. So we'll touch upon these. I'll not tell you how to, I'll not make you code there, right? Coding is something which you need to, which you will learn with time, with practice, and you cannot practice in a course. So you just understand the application, which is the most important part of this course. I think Python is very easy to learn, and you can learn it anytime. So don't focus too much on Python. What are these libraries used for? Scientific and technical computing, for example, NumPy is used for, or Matplotlib is used for visualization, or Pandas is used for data aggregation, and whatever it is. I'll talk to you about structuring machine learning projects also. This is again subject to time availability, and if you guys want it, it's totally up to you. It's however you want to do it, I'm ready to do it. That's okay, because it's about you. It's about the next generation of petroleum engineers. It's not about me. I've been doing this for the last 5 years, so that's okay. So with this